Okay, sorry about that. The video cut out on me, and but at least I noticed it before I went any further. So we had just done this one, SSA. You could also do AAS, which you could also list backwards as SAA. Now, these two are the same thing. So, again, like I said, you could also list one the other way, but you're not going to have to worry about it because there's a few that work and a few that don't work. And guess what? This one won't work. Now, the difference between some of these, because you'll notice we have SAS and SSA. This is saying we have two sides and an angle. This is also saying we have two sides and an angle. Right? The difference between this one and this one is this is two sides and included angle. So tying back in the vocabulary from up at the top, because if we're listing it in this order, it's saying we have two sides and an included angle. Two sides and included angle. Whereas this one is saying two sides and the non-included angle. So then, same difference here. This is saying we have two angles and included side, whereas this is two angles and a non-included side. So again, two angles, I'm going to abbreviate, and included side. This one is saying two angles and non-included side. So that's the big difference, because the order that this is in is actually telling us how they appear in the triangle. So for example, down here on these two examples. Now, these two examples are examples of things that don't work. So again, there are 6 possibilities just using angles and sides. However, 2 of them don't work. This one doesn't work, and if you notice, what we have here is we have an angle, and another angle. So we have all 3 angles listed. Same thing here. Angle, angle, and angle. All 3 angles. They have the same angle measures, but these two triangles are definitely not congruent. They are 2 different sizes. We talked about this idea a little bit when we had our equilateral triangles in the last section. We had a question that made you think a little bit about equilateral triangles where all the angles are 60 degrees, but that doesn't mean that triangles would be the same. They wouldn't be congruent because we don't know anything about their sides. So angles can all be the same, can all be congruent without the sides being the same length. So this is one that doesn't work. So going back up to this one, you can go ahead and cross that one off. That doesn't work. Also, if you look at the next one over here, so this was angle, angle, angle. This one we have an angle and 2 sides. This one we also have an angle and 2 sides. Well, again, I'm not going to list out in the order of angle and 2 sides for the purposes of not trying to spell anything, but I'll go the other way, SSA. So we have 2 sides and an angle, and the angle is not the one in between them, so it's SSA, 2 sides and the non-included angle. So this one, we can see there's a possibility of 2 different triangles that we could create with those pieces. Since we're not always going to get the same triangles using side-side angle, it doesn't work and it cannot be used as one of our shortcuts. So this one also doesn't work. Now, the other 4 that are up here all work as shortcuts. Now, on this paper, I use the word congruency conjectures because I made this back when we used a different book, and we said that they were conjectures first, and we went through proofs and proved them to be theorems. Our book just calls them congruency criteria and doesn't go through the proof because there's not a... They don't give us all... We haven't gone over all the information necessary in order to do the proof for these yet. So you can either call these triangle congruency criteria, like our book calls them, or triangle congruency theorems, and I'm fine with either one. Now, for down at the bottom, so which of the 6 combinations is it proving wrong? Again, it's proving wrong the AAA and the SSA. Those two don't work. All the others do. Now, going on to the back, so you'll see it says we have these 3 triangle congruency conjectures. Again, instead of using the word conjecture, your book uses the word criteria because we are not going to go through the proof of these. However, in the next few sections, we are going to use these within a proof. So I'm fine with you either calling them congruency criteria or congruency theorems, because we can prove these. Our book just doesn't go in an order where we have the ability to prove them yet. So you'll see SSS. If the 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. So if you know that all 3 sides are congruent, that's enough information to say that everything in the triangle would have to be congruent. SAS, congruency conjecture, or again, congruency theorem, or congruency criteria. If 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the triangles are congruent. So again, same idea on each one of these. It's saying that if you have these 3 pieces given to you and they are congruent, then the 2 triangles must be congruent. So we're going to be using these in proofs in the next section. Down here, I just want to go over, is there enough information to say whether or not these triangles are congruent? So take a minute, pause the video. I'd say actually take like 2 minutes and pause the video and see if you can identify which criteria is used here and whether or not we can tell if they are congruent. After 2 minutes, go ahead and resume play. So now that you've taken a look at it, let's go over the answers. On here, we have these 2 triangles, and we can say that these 2 are congruent. Now, when you first look at this, you might say, well, we only have 2 sides given to us in each one of these. But we know more than what's just labeled on this figure. So you have to look a little bit further. In these 2, we also know that these 2 angles should be congruent because they are vertical angles. So we have vertical angle theorem. So now, going in order here, we have side, angle, side in that triangle, and side, angle, side in that triangle. So this would be SAS, and you could say that these are congruent through SAS. So, again, congruent by SAS. On this one, all right, we now have 2 triangles. Again, 2 of the sides are labeled. This other side is not labeled. However, it's the same piece in both triangles, so it's congruent to itself. Now, that is a property from algebra called the reflexive property. If you have the same piece set equal to itself, you'd call it reflexive. Same thing in a diagram for geometry. If you have a diagram where you're sharing the same line in 2 separate figures, it is congruent to itself through the reflexive property. So here we have all 3 sides of this triangle, side, side, side. And then if we were to label this one, side, side, side. So we can say that these are congruent by side, side, side. On this one, we have 2 angles in both triangles. So again, angle, 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 angle. We also have a side in each triangle. So side, angle, angle. Or again, we could go the other way, angle, angle, side. So we could say congruent by side, angle, angle, or angle, angle, side. These both mean the same thing. We have 2 angles and a non-included side. Again, the S is purposely not between the 2 A's because it's not the side that's between the 2 A's labeled in the triangle. On this one, we have 3 pieces. We have the angle, angle, and side of this triangle, and then angle, angle, and a side of this triangle. But now this time, the side is in between the 2 angles. Therefore, it's an included side. So we have congruent by ASA. On this one, we have 2 sides given to us, plus the one that they're sharing in the middle. So this would also be congruent by side, side, side. On this one, now, you have to use other properties in order to identify some of these pieces. So we have the reflexive property, and we can say this one's congruent. But we can also say, since we have parallel lines, this is touching both parallel lines, so this would be a transversal. So we could say that alternate interior angles are congruent. Therefore, we can say these 2 triangles are congruent by angle, side, angle, side. So side, angle, side. Or if you look at this triangle, side, angle, side. And then the last 2. So again, parallel lines. There's more than one way that you can state these are the same. Because, oh, sorry, I'm getting to the next figure. On this one, is there enough information? So are there any sides labeled first off? No, there's no sides, so we can't say this one is congruent. What we could see is that we have vertical angles are congruent. We have alternate interior angles are congruent. But that's only enough information to say all 3 angles are congruent. Again, AAA doesn't work. So there's not enough information to say these are congruent. This one, there's more than enough information. We can label the same things that we just labeled on this figure, but they also gave us a side. So if we were to label this one, same as we just did the last figure. Again, vertical angles, alternate interior angles, alternate interior angles, and then we also have a side. So now we have a couple options. We can do the 2 angles and the include side, so by angle, side, angle. Or we could use 2 angles and the non-included side. So we could also use angle, angle, side, which is also able to be written as side, angle, angle. So any of those work. So these ones are congruent by any of those. And that's it. Again, you have an assignment to do in your Springboard book. So if you look at activity 11 and go to the back part of it, which is on page, find the right page, page 165, your homework or classwork is on page 165, numbers 1 through 11. It's based off of what we did on here and what we did the other day. All right. Again, sorry I couldn't be here, but make sure you get that done for class. As for the extra credit, if you were not able to log on, I can help you with it tomorrow. So I will allow it to be finished on Wednesday if you're having login problems. So talk to me on Wednesday if you're not able to log on. Otherwise, you should be trying to wrap it up tonight. Again, if you're not able to log in, contact me either through Edsby or Remind. Send me a message saying that you're unable to log in, and then I can get with you tomorrow and try to get you finish it in class. All right? Have a good one.